Hey, it's Mr. T. I want to do a follow-up video to the skew the script video that we saw a second ago and talk about the sampling distribution for sample proportions. This is sometimes called the central limit theorem of statistics or the fundamental limit theorem of statistics. So this is a big idea and it's pretty awesome. Let me show you a few things. First of all, whenever we talk about sampling distribution for proportions and we say we're expecting this shape, that's not a guarantee. Next lesson is going to be dedicated to how do you know for sure that you're going to get a normal curve. But we know that we can expect a normal curve in most cases and more on that to come. The thing that I really want you to remember about this normal curve is that inside of this normal curve is billions and billions and billions of possible sample proportions in theory. So one of the things I'd encourage you to do is to keep track that this is many p-hats. And in theory, it's all of them, all possible sample proportions you would ever get. The center of all those p-hats should be the true population proportion p, and the spread can be calculated as the square root of p times 1 minus p over n, and that's what he used in the video. I would label this and make a good habit of labeling this as sigma sub p hat. That's good notation. Makes you remember that this is the standard deviation of all possible sample proportions. If you like some shorthand notation, you can write it as PQ over N, and there you can write it shorter. So where does this come from? From the binomial distribution, we're using a lot of the same language. We're saying proportion, we're saying percent of success. It's all really kind of the same thing. So if we go back to the binomial model, we can remember that for the mean, we take N times P. So remember, like if I have a coin toss, I'm going to toss it 40 times. I can say the mean, the expected value is going to be 40 times 0.5. I would expect 20 heads if I tossed a coin 40 times. And the standard deviation, a little bit more math on that, led to square root of NPQ. So when we transition from binomial to proportion distributions, all we're really doing is changing it from counts to proportions. So grab this mean, NP, and divide it by N. Sweet. The expected value is P. And that's not a big surprise, but here's what's really cool. That formula that you got a second ago. Let's start out with square root of NPQ. And that's supposed to be a Q. Let's divide it by N. That's a little messy, so let's rearrange it to where it's the square root of the top and bottom. So to put this inside the bottom of square root, I would write that as N squared. NPQ on top, and then simplify N over N squared, and we get square root of PQ over N. I don't know why I can't draw my Q's today. But there you go. That's where the formula comes from. Thanks for watching.